Hi all, myself Dr. K. Ashok, Associate Professor in Physics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about semiconductor physics. See, under the semiconductor physics, I am going to discuss about basic introduction of semiconductors and intrinsic and extrinsic semiconductors. That is nothing but type of semiconductor, different types of semiconductors. So here, see, usually the highest occupied electrons, that band is called valency band. The lowest unoccupied band is called conduction band. See here, the valency band and conduction band are separated by certain distance. That is called forbidden gap or energy gap, where that is empty space. So based on this energy gap, the materials are classified into three categories based on the energy gap. The first one is the conductors. See here, in conductors, the valency band and conduction band are overlapped, so that energy gap is 0 electron volts. So when there is no energy gap, the electrons are freely can move from valency band to conduction band. No need to supply any additional energy to move electrons from valency band to conduction band. The second type of materials are insulators, where the energy gap between valency band and conduction band is very high. So usually this value is greater than 3 electron volts. So you need to supply that much of energy to excite electrons from valency band to conduction band. But supplying of that much of energy is very difficult. But in nature, certain materials like insulators can be converted into conductors by supplying very high energy. So next type of materials are semiconductors. In the name only it is there, semiconductors. That is nothing but partial conductors. Sometimes they act as conductors, some other type they act as insulators. Suppose if you consider at 0 Kelvin, okay, all the electrons are bound to valency band. That's why it acts as insulator. At room temperature, that is approximately 300 Kelvin, what happened, these electrons gains the energy and excited to conduction band. So that's why here at room temperature, the semiconductors will act as like partial conductors. See, the energy gap, that is nothing but the gap between valency band and conduction band, is optimum, means which value is lies between conductors and insulators. Means conductors, the energy gap is 0 electron volts, whereas for insulators the energy gap is 3 electron volts. For semiconductors, the energy gap is lies between like 0.75 electron volts to 1.1 electron volts. So this is the usual values. See, in nature there are two types of semiconductors are available. So those are nothing but intrinsic semiconductors, means they are available in pure form. Pure form semiconductors are called intrinsic semiconductors. Here the examples of intrinsic semiconductors are germanium and silicon. And see here, if you are doping these intrinsic semiconductors with different dopants, then they are called extrinsic semiconductors. See, based on the purity, we are classifying semiconductors are two types. One is intrinsic semiconductor, another is extrinsic semiconductor. Again, extrinsic semiconductors are classified into two categories, P-type semiconductor and N-type semiconductor. So in further time we will discuss about how we will obtain p-type semiconductor and n-type semiconductors. Now primarily we'll focus on intrinsic semiconductors. See here, different types of intrinsic semiconductors available in nature are germanium and silicon. Germanium and silicon, both of them are tetravalent elements. Tetravalent elements. What is the meaning of tetravalent elements? Here, the outermost orbit contains 4 valency electrons. So see here, when you consider like tetravalent elements like silicon. So here the outermost orbit contains 4 valency electrons. See the electronic configuration 1s2, 2s2 and 2p6, 3s2 and 3p2. So here third level contains 4 valency electrons. These all electrons are innermost electrons, they are completely bonded. So these 4 electrons are available in silicon. When you consider like germanium, see here the germanium, see the atomic number is 32. The atomic number of germanium is 32. So when you consider outermost orbit like 4s2, 4p2, so totally 4 valency electrons are available. Now see, whenever this element wants to react with other element, either it needs to lose 4 valency electrons or else gain 4 valency electrons. This is very difficult. That's why sharing of electrons will takes place. When you consider like, see here, you can observe that sharing of valency electrons takes place. That's why valency bond is formed between the neighboring silicon atoms. So this is about the pure intrinsic semiconductor. Here covalently bonded, okay, metal will be formed. Next, when you consider intrinsic semiconductor, if you supply like thermal energy, that is nothing but when you heat it, automatically electrons will excite from valency band to conduction band. So then see here how many electrons are excited, that many holes are formed in valency band. That's why in intrinsic semiconductor, number of electrons are equals to number of holes. Number of electrons equals to number of holes. Here the conductivity is happening because of temperature. So see here, these are the properties of intrinsic semiconductors. The first one is, in an intrinsic semiconductor, the number of electrons are equals to number of holes. That's why in an intrinsic semiconductor, the Fermi level is exactly between the valency band and conduction band. This down one is valency band and this one is conduction band. See, the Fermi level is exactly middle of the valency band and conduction band. So in an intrinsic semiconductor, the main drawback is conductivity cannot be controlled from outside. Because of the temperature, the conductivity is varying. So to overcome these drawbacks, what we did means doping we will do. So because of this doping means what? Adding of impurities to intrinsic semiconductor. The process of adding impurities to the intrinsic semiconductors, then such type of semiconductors are called extrinsic semiconductors. Okay, we will discuss about extrinsic semiconductors in the next video.